Hello, everyone. Welcome to today's webinar. So I'm Peter again. Nice to see everyone here. Okay, so today we're going to switch gears a little bit. We're no longer just focusing on HMI. We at Weintek, we want to provide a more complete and more integrated solution, control solution for all. We'll be introducing controller solutions, which for us consists of Codesys controller and IR series. And the IR series are a family of remote I/O modules. Okay, so those are the main topics we do today. So here's the outline table. We'll look at basically the Codesys, the remote I/Os, basically their features individually. And as a bonus, we're gonna do a little bit of hands-on walkthrough. So I'll do some software operations to try to get you started, basically from scratch, how you might start from a brand new project and then go into being able to control our digital I/O, for example. And I also work with a software utility called the Easy Remote I/O that will help you basically organize your Ethernet-based IR couplers. Okay, so let's get started. Okay, so our Codesys solution or controller solutions is built into one of our CMT models with screens. So those are the 7-inch model, 9-inch model, and 15-inch model. So the CMT 3071, 3072, 3090, and 3151. And these HMIs, you can basically, as an option, activate a license on these to run Codesys. Okay, so Codesys, if you are not familiar with it, Codesys is essentially a software-based PLC, and it's fully compliant with the IEC 61131-3 standard, and that's a standard for nowadays PLC development environment. Okay, so our HMI will basically function as a controller when it's activated with Codesys. Okay, then also we have the Codesys as a brain for control, but how do you actually do the control itself? It's through the IR series with the remote I/Os. Okay, so the IR series has basically two parts. One is the coupler. Okay, so the coupler will basically handle the communication from the master. So the master would be your Codesys, for example, or maybe your other controller, as long as it supports the protocols they use. So far we have released CANopen and the Modbus, basically the Modbus, so the Ethernet-based couplers. And in the future, we probably will release more couplers that support other bus protocols. And so with the couplers, and there's also the actual I/Os for physical control. So the digital I/Os and the analog I/Os, they'll actually take the physical values from basically from the environment or output the value to the things they will control. So in the later part of today's session, we'll talk about the IR series in a little more detail. So how does it work though? So in order to realize this HMI Codesys architecture, so there's kind of like a story behind why we have to work on CMT models. It's because we have to utilize its dual core processing architecture. Okay, so with its dual core processors, we can run independent operating systems on this processor. So with that, we basically could split our HMI basically split it into two independent parts. So one part is the HMI logic. So what we already knew about, what already worked with our HMI, the drawing, the graphs, the communication with PLCs, etc., it will run on one of the core of the processors. And the other core now will be activated to do work exclusively for the Codesys PLC logic. Okay, so these kind of architecture will benefit. You'll benefit from this kind of architecture because they are completely separated. So you probably might have the kind of question that, okay, if I combine HMI and Codesys together, if my HMI for some reason, I have a bad graphics that cause it to crash, would it affect my control logic? Well, with this kind of architecture, because they're completely independent, okay, so in this case, your PLC will be just fine. Okay, of course, the reverse is true. So if anything goes wrong in the Codesys side, the HMI will function just as fine. But I don't think anyone wants to see that. So it's just as an example. Okay, so once you have your HMI activated to have this kind of architecture, it's actually a fundamental change. So once you activate it, it will be like this basically forever. So if you don't activate your HMI to have Codesys, it will just run like a usual HMI. So both cores will work for the HMI functions. Okay, so when we have this kind of architecture, unfortunately, we have a limited number of physical ports on the HMI. So they will have to be shared between HMI and Codesys. So this is on this slide, you see the destination of which gets which. Okay, so the HMI will have one Ethernet port and 3 serial ports for all its functions, and Codesys gets 1 Ethernet port and 1 CAN bus. Okay, so because the systems, like I said just before, they're completely independent, so these ports cannot be shared. So once you activate it this way, the Ethernet ports are separate, one for HMI, one for Codesys. They cannot be shared. So the real benefit of this architecture is actually what we talked before was more on the background. Now I talked about kind of like the real benefit or the real distinct feature of this architecture. It's that within the HMI, basically within the machine itself, we develop internal communication schemes so that the HMIs and Codesys, they can talk to each other through an internal channel that we devise. So HMI and PLC's communication will become a no issue as it turns out. Okay, so in this kind of work, Codesys is doing some control with the remote I/O. Your HMI basically can communicate with the internal Codesys, and there's not much to set up, as we'll see now. So now I'll do the first part of our hands-on. Okay, so in this part, I'm going to show you how this internal communication works. Okay, so there's actually 2 ways. Okay, so for HMI to the Codesys PLC, we have a specialized driver in the HMI. So this driver is called the Weintek built-in Codesys, and you can use this driver to access the Codesys inside the HMI. Okay, so now let's go through the actual hands-on. Let's see how you might do this. Okay, so as I said, we will use the CMT series, and I'll take the stable model, the 3090, as an example here. Okay, so I create a new project. Okay, so just as I said, to access the Codesys, it's treated as basically as a driver, as a PLC driver. Okay, so it already selected for me. So basically, you can find it within the list of all the companies. We have our own company here. So you see there's a building Codesys and remote IOs. But now here, we want the Codesys. Okay, so we're now here, and well, with the Codesys, the thing is that it's a tag-based communication. So you do have to import a tags in order to work on it. Okay, so with that, so I show you first how you do that, but you don't have that. We don't have the tags yet, but I have the sample tags here. So this is example tag file. So the tag file comes in the XML file. I'll show you in very short time that how this is generated. Okay, so when you import it, you see the success. Okay, once you have successfully imported, then you can use it in your objects, in your lamps, in your buttons. Okay, so this is how you can utilize the Codesys internal Codesys communication in EB Pro. So when after you have downloaded into your HMI, this will communicate directly with the Codesys inside your HMI. Okay. So what about the other way? Okay, so on the other hand, our Codesys can access the data on the HMI itself, and this is done through what's called a Modbus gateway. So if you have used our HMI before, you knew a Modbus gateway. We have a Modbus server on the HMI, and some Modbus master will be able to access our HMI with this Modbus gateway feature. So basically, the Codesys only has to use the Modbus protocol to get data from the HMI. In order to do so, it will have to use an internal IP address. So the internal IP address is, in this case, it's basically fixed in our system would be like this and shown here. Okay, so if you kind of extend it further, we know that this Modbus gateway can be extended so that this Modbus correspondence actually goes to the PLC address that the HMI is communicating. So in doing so, that means that our built-in Codesys PLC can actually access another PLC that's connected to the HMI. So this is actually quite a distinct feature because usually the communication between one PLC and another PLC can be quite tough. So in this kind of architecture, it becomes quite easy that our Codesys PLC can exchange data with another external PLC. So this PLC here we will use, I'll do an example right now. We take the example for a Mitsubishi PLC. Okay, so now I actually have an HMI that's connected to Mitsubishi PLC, and it's right here. I can, because of time, I won't do the downloaded right on the spot, but I can show you. I show you where it is, and I'll do the Codesys part. Okay. So this is actually an actual HMI that is connected to an Mitsubishi PLC through the serial port. So this is I can do a switches on this guy. Okay. So now I want to start my project in the Codesys, and we'll try to access this PLC. through the internal communication methods in this shown here. Okay. Okay, so here I'm starting from scratch. So to start from scratch, so just kind of backtrack a little bit. When you, if you're using our Codesys system, after you install, you should be getting a version of 3.5.10. Okay, so this is the standard version that we support. Okay, and also after you've installed the Codesys system, you also install basically a description files that would basically put in the descriptions on our specific Codesys system. So after you have done that, okay, then when you create your Codesys new project, okay, it's heavy. Okay, so the Weintek built-in Codesys will be in the device list, and this will be the one that's compatible with our system. Okay, so to get it working, let me do a few things that would get it to work. So let me just make sure I can connect to the Codesys HMI I have. So this one, the one we're doing is the 10D9 right here. So make sure, okay, I can scan for it so that I can access and download it to that one later. Okay, so let's see what else should we do. Okay, so like I said, well, we have to connect to the HMI through a Modbus gateway. So basically, our Codesys will have to define. We have defined a Ethernet access, Ethernet ports for our Codesys system. So to do that, we will need to add it. Sorry, we have to add device. So basically, the first level, you're adding a device saying that, okay, I have an Ethernet interface. Okay. And then you add on top of that, you define another one saying, okay, I am a Modbus TCP master. Okay. And then you add another device under it saying that this is what I want to connect to. So that's a Modbus TCP slave. Okay, so this is the kind of configuration you need to first do. And okay, so and let's do some config too. And if, okay, sorry. Like I said, we have to, in order to do this internal communication, we're going to use the internal IP interface. Okay, so if you search for it, it's okay inside here. So here you have we see the VNet one. It's the internal one. Okay, so and the other one, this one is the external one. So this one actually goes out from the HMI's physical port. But for now, we're doing the internal one. So we do this. Okay. And in this Modbus master, we want to select the auto connect just to make our life easier. Okay. Okay, so and the IP of the internal would be, I think it was 10.255.255.1, and United was 1. Okay. Okay, so for the first example, okay, Now I need to go to the programming screen. I should define some variables for use. So in the definition place, I can define. Okay, I defined. Okay, defined very quickly. It's x. Okay, I'll just define a. Okay. And also define an out. Okay. Okay. So, and I can do a very simple network that can be used here. Okay, so we're just starting from scratch. So once you have defined your variables, you can use it in your ladder program. Okay, so I put it on, I put this variable in the contact and add another coil and set it to the out one. Okay. Okay, so that's basically a starter. Okay, now I can go back to the TCP slave setup, where first I should set up a channel to write data. So here in this example, I want to write to the M address of the Mitsubishi PLC. Okay, so I just do it like this. Channel 0 and length of 1. Okay, that's fine. And then I need to add the address mapping. Okay, where's the mapping? Should I save this? Oops. I think there's a. I should have the link. Let's see. Okay, let's see which one I'm missing. I should be getting a. Okay. It's okay. I'll use a preset project, then we can figure that one later. Okay, so I have a preset project that I worked with before. So I think for the time, I think I should just show you the preset project instead. Okay, so you had done similar things, then so here I did exactly the same thing. But okay, but in the variable part, okay, I will assign the variable to the channel. So this is where you would assign the variables, okay, to the channel that you define in right up there. Okay, so when you do this, I think let me just double check other things. So these are all exactly what we had said before. Okay, so when you're done all the setup, then you can oh yeah. Okay, just making sure I still have my active connection. I'll just do it again. It's fine. Okay, so let's just, after I change the project, just make sure I still have the right connection. So right now I log into the project, so that would download this my Codesys project to the my Codesys. Okay, and then I can run the project. Okay, so now let's see. So yeah, this is the hard part. I have to show you both on the same screen. Okay. So here I can try to write to, let's see, I try to write to the input. So when it's running, it will also write to the output. Shoot, like that. Okay, so I try to write to the input. So it writes to the output. So the output will write to basically through the Modbus gateway, and then it will write eventually to the Mitsubishi's memory point. Okay. So that's the first part of my little demo today. Okay, so what did this tell us though? So usually we program our Codesys through its own Ethernet ports. So on the right, you see here. Okay, but there's a function, what's called the Ethernet, or we call it internal pass-through, that will allows you to actually go through this through the Ethernet port of your HMI. Okay. So, and if you want to use this, then you have to enable an option in the system setting called the Codesys login. So when you check that box in the system setting, so if you want to program it through your Ethernet port, basically the Ethernet IP of your HMI, it's fine too. If you want to do it through the Codesys one, it works too. So what this means is that when you use the Easy Access 2.0, so the Easy Access 2.0 will help you get an IP address, basically a remote IP address for your HMI. But with this, basically you can update your HMI project and also your Codesys project because of this internal pass-through mechanism. Okay, so in terms of some other things, we have done the performance comparison with other PLCs. So the pink ones are the basic lines, and there are gray ones which are considered mid-higher end. So we've done this test based on the average scan time for the load instructions. So it's quite evident that in the test that our CMT kind of architecture is pretty much comparable to the mid to higher end one PLC. Sorry, I think I made a mistake when I said the pink one was basic, but I meant the pink one was the higher end ones, and the gray one was the basic ones. Okay. So this could lead to potential cost savings when you purchase an HMI and PLC separately. You might incur a higher cost than if you had an HMI plus PLC package. And this might not seem so obvious when you're just using lower end models, but if you are using kind of more advanced features like those features in HMI that's not found in other places, like the IoT features like the OPC or the MQTT or the SQL connectivity features in HMIs, then if you need these and also a mid-higher end PLC to work with, then definitely you'll see a lot of cost saving when you have combined these into one CMT model. Okay, so that was about the Codesys in the first part. So now let's move to the IR series. So the IR series, basically, there's basically three parts that we can concern with. First is the couplers, and then the digital I/O and the analog I/Os. So the digital I/Os has all sort of combinations, just like I think this is pretty much common to many other things you see in the market. So there's input only, output only, or a combination of both. and the output, there's a relay output, transistor output, and then we can, and for the input type, there's a sink source difference that basically we can, these, with all the combinations we have the associate model for you to choose. Okay, so we talk about the couplers and digital part first. So the couplers, basically the first one, there's the iR-COP. So this one is the coupler for the CANopen, basically CAN bus. So based on CANopen protocol. Some features of it are the auto baud rate, and you can adjust your baud rate and station number on the device itself. So there's the buttons, and the little dip switches and the arrow type button that you can for you to adjust. And if you're working with Codesys, and we do provide a Codesys library for you to basically do the configuration of the couplers and the IOs. And just as I think you saw it when I was adding a driver in EP Pro, there was remote IO CANopen driver. So basically, you can use, if you do not want to use, or you do not need to have an actual controller for to control these IR series remote IOs, then you can even use the HMI itself. Basically, you will just go on the CAN bus to control these devices. Okay, then the other one is the Ethernet one. Okay, so the Ethernet ones are couplers which work as the Modbus TCP slave. Okay, so you can configure with your own Modbus protocol, or we do provide an easy utility that's the easy remote IO, and we're gonna do the easy remote IO shortly and see how this easy remote IO will work with configuring and checking what's going on with your iR-ETN. Okay, also there's also easy EP Pro driver support, and it does have 2 Ethernet ports, as you can see in this little picture. Okay, so the point of these 2 Ethernet ports is basically to save you switches and to simplify your configuration. So if you have many of them before, you might have to organize switches to do that. But our idea is that you can do what was called the Ethernet cascading, that would daisy chain your Ethernet devices so that your controller will go to the first device and occupy 1 port, and the rest will be connected to each other. And the other one, the very end one, we will allow kind of for you or the operator to download a program and do maintenance work, for example. Okay, a little bit about the design of the series. So it works, you can install it on, it has a clip fixture on the back, so you can install it on a 35mm DIN rail, and you can basically stack one on top of each other, and you can basically mix and match all the IOs that you need and you want. In terms of the structural strength, we do have, it does have a little design that would allow you to put fixture clips that holds the two, each 2 of them together. Okay, so actually, if you install it on the rail and they're all fixed on the rail, they're probably sturdy enough already. But if you wanted to even have a more better peace of mind, then you can have this fixture clip to enhance its structural integrity. Okay, more on to the design itself. So the actual terminal block, we featured a plug-in installation with screwless design. So basically, for installation, you can basically just plug it into the hole and you're done. But when you want to remove it, you can just press onto the little thing beside the hole with your flathead screwdriver. It will releases your wires from the terminal block. Okay, so now the second part of our hands-on is that we want to try to use our Codesys to connect to connect to an iR-ETN. Okay, an iR-ETN, and then we try to maybe change the output of a point. Okay, so first, before that, I'm going to introduce you to this little software called the Easy Remote I/O. So this is a program that's developed in-house, and it will do a lot of the little neat things like what I'm showing you now. So you can scan on your network. You can scan on your network. So what iR-ETN modules are on the network. So right now I'm doing the scanning. I just done the scanning, and it shows there are 4 Ethernet couplers that's on my network. And the one I'm trying to show to you today is this one. So I just leave this one checked, and I add it to my project. Okay. So this is my coupler. So it basically already showed me like what's under this coupler. So there are 3 modules behind it. So number 1 is a digital one, the second one is the analog output, and third one was the analog input. Okay, so we'll do the analog one later. We'll check with the digital ones first. Okay, so on this software, you can it will basically use the Modbus protocol for you to monitor all the key parameters on your modules. Okay, so I just hit the start monitoring all. Basically, it will monitor all the values. So it'll show here. So this is in this tab, I see the all the online values, the actual values of the digital input and output. Okay, so and there's a parameter page for you to basically check all the parameters. So if without this software, basically you have to go through our user manual. So our user manual says it very clearly which Modbus address functions as what. And if you want to do that, by all means, that's fine. But if you don't want to, we have this utility software that helps you basically save you a lot of work. Okay, so I'm just gonna stop it for this. I'm just gonna leave it here. So you see we can monitor the output here. So right now I'm going to go to the Codesys, and I'll try to use our Codesys controller to connect to our Ethernet coupler, and then I'll basically change the value of an digital output, and you'll see the value will be changed and shown here. Okay, so for that I'm going to use the program that I've compiled already before we started this webinar. Okay. Yeah, although I cannot basically go step by step with you, but I'll highlight the key differences and the key settings that's required. Okay, so for this, my Codesys now is working. It's using its external Ethernet to connect to the coupler. So here, instead of choosing the internal ones, now I'm choosing the external one. So that's the ETH0. Okay. Oops, sorry. Again, I have to confirm my connection with it first. So I do that first. Okay, so now I do have to choose the ETH0, this one. Okay, so that's the Ethernet interface that I will use on the Codesys, so the HMI Codesys Ethernet port. Okay, so on the IP address, I have it set as like this. Okay, and then for the coupler will, as I said, will work as the Modbus slave. So here, this Modbus slave will basically represent the Ethernet coupler now. So this address, IP address here, is the IP address of the coupler. So right in my Easy Remote I/O, when I scan it, I already got it. So it was, oops. Yeah, can you see it? It was the 38. So 0.1, 0.38. Okay. So this is how exactly I set it. So I had to set it to 0.1, 0.38, and the unit ID is 1. The port is 502 as most Modbus devices. Okay. And I added the channels. So this is according to the Modbus protocols. I'm going to use function code 2 and function code 15 to do reading and writing of inputs and coils. And just as before, I will do exactly the same map. I'll do the mappings in this mapping tab. So I'll map the input bit to channel 0 and the output bit to channel 1. Okay, so now when I can return to, so this is basically the same as we had just seen before. So now we return to our program. Let's log in and download this part of the software into the Codesys. And we'll let it run. Okay. Okay, so now the controller is running. So basically it's what it does is that if I have an output, if my output changes here on the right, the coil. So if the coil changes, because it's mapped to the digital output, so digital output should change as well. Now it's 0, so we can verify it's zero right now. Okay, so it's 0. And now let's do a change here. So, okay, so now I'm gonna change the input, but because the software is running, so if you knew a little bit about it, I cannot really change an input. Okay, but I can force it so that the software thinks it's changed, and it will change the output anyways, and that would eventually will change the actual output to the digital output. Okay, so here I'll use a force method to effect an input change. So I've prepared a true value here, and I'll do I'll force change. Okay, so once it's force change, the output has changed to on as well, and we can see, okay, so that's exactly what we were expecting. So the digital output was the actual of the actual I/O has been turned on. So this was showing that we have used the Codesys to control our digital output through our Ethernet coupler. Okay. All right. So let's erase these and move on. Okay, now let's move on to the analog ones. So it's not a lot of difference. Well, the exterior outside looks pretty much similar, but it's the analog one. So it has the 4 points. It has the input ones, output ones, or the input mixed with output ones, and one with temperature input detection. Okay. Okay, so you can see in this table that it has all of them have all the voltage and current modes, and the input resolution and output resolutions are 16 and 12 bits respectively, and featuring 2 millisecond conversion rate, which could be faster to, I think it's 4 times faster if you only use one channel. Okay, so that's documented in the manual. As for the we'll talk about the temperature later. Okay, so it's pretty much might be similar to other other IOs. So I'll just talk about more features that's specific to ours. So all our models, they feature all the common modes. So between -10 to 10 volts, etc., or like the 4 milliamp to 20 milliamps. So these are supported on all of them. So it's not one or another. So it's really a one size fit all solution. You don't really you don't really have to worry about which model to choose, because basically our IO would solve all the conversion problem for you, as we'll see in the short. So if you have input output that's in different range, even if they're both voltage, you can convert them. Or even if maybe they're converted already through different drivers, and they are probably in one in voltage and the other in current, it's no problem too, because our analog input modules support all of them. Okay, we also support a channel detection mechanism. So this is pretty straightforward, that when any of the channels goes through an open circuit or short circuits, and for either input or output, doesn't matter, we have it's available for both. There is a predefined alarm that will send out that you can be programmed to send out to your controller. So it's easy for you to respond to the system issues. Another feature is that we have what's called the output update time. So this is an update time that you can define so that your output doesn't output a step function. Instead, it's a linear function that would basically be raised to the maximum value after a specific time. Okay, so this will give you a gradual start effect. So for example, if you are doing like a movement control of a conveyor belt, then it's like one of those escalators that start slowly and then slowly goes to its maximum speed, so that it doesn't just jumpstart very suddenly. That will hurt people. Also, there's an input filter frame that you can set so that if there's noise in your signals, this could possibly get you a better signal eventually. Okay, so then now I'm gonna show very quickly with our easy remote IO that how these are working on our analog modules. So you can see this now. The picture you see is the connections I have here. So I have an analog output and an analog input. This is what we saw in the easy remote IO. So the input and output of the analog modules are connected. The channel 0 of them are connected. So let me just demonstrate very quickly what those 3 features that we just talked about, what they mean. Okay. Okay, so let me come back to the remote I/O utility program. So you can see there are, in the parameter tab, there are all the modes that I just talked about. There are parameters that you can set. Okay, so if you had, if this is the current settings I have for output and input. Okay, so you can note this is the current setting of channel 0. Okay, so you see our output range is now from 0 to 30,000, and it's working for 4 to 20 milliamp range. And my input here, okay, the input, let me just get it aligned. Okay, the input one, the range is 1,000 and 0. Okay, but the modes are the same. So if you do a really quick calculations, sorry about the markers. If you do really quick calculations, you'll find that by the conversion, if this data, if my output is now, for example, 18,500, then this would map to an input of approximately 600-ish, 618. And I will show you that that's just the case. So, okay, now the output is 30,000, so it's the max. So you see that we are getting almost the max. So of course there's a little variation. So almost the max, almost 1,000. And if we are just to verify our claim, if my output is now 18,500, and then I just write it to it, and we see the input has changed to 615. Okay, so it's that's about right. Okay, and because I set the update time to 1,000. So 1,000 in this unit is 1,000 of 100th of the second. So 1,000 is 10 seconds. So what this means is that in 10 seconds, the output can go from minimum to max. So this is the exact definition of it. So if I can I'll just show you that. Let me just reset everything to 0 now. Okay, well, you already see the effect that when I just set it to 0, but the input is not immediately changed to 0. It actually goes down slowly, and that's the effect of the graduate output. Okay, I just try to set it back on again. So supposedly it should take 10 seconds for the input to go from 0 to its max value. Okay. Okay, so one last thing though, about the channel detection. Okay, so now I asked my colleague to basically break the connection between the input and output. We'll see what happens. Okay, I'm just calling them. Oh, okay, he's done it. Okay, so when he just basically break the wire between the input and output, and you see that the error already comes out, and basically you can report this to your control system or HMI. Then your people can respond to this very quickly. Okay, now I ask them to put it back on. Let's see. Okay, so now it's back on, then the error is gone. So this is the basically the automatic error detection mechanism that we provide in our analog input and output modules, which will be convenient for you to use, for all to use. Okay, so lastly, there's the temperature input module. So this is basically just a variation of the analog input. So except that we have already calibrated with most types of thermocouples and RTDs, resistant temperature detectors, so that the input values that we get from the modules will be the temperature already, or the resistance, if the resistance is what you want. Okay, so we support most of the common types of TCs and RTDs, and just in the very rare case that, well, we document all of those in the manuals, of course. And just in the rare case that it's not enough, we do have the option for you to put in your own user-defined profile, and you can download it to your analog module, and you can use your own profile of your own TC or RTD. So this one doesn't have a temperature, but it's right here where you can go in there and define your table, download the table, and then put it into your module. Okay. So now the last part, very quickly. I go through this. So the one big benefit of using Codesys is that you have access to many libraries that will facilitate building your own controllers. And these libraries would come in free of charge, or there are people that supply them for a fee. So far, as a starter, we do provide a PID control library function block for our users. So the PID control is popular in temperature control applications, and it basically uses the output feedback to calculate the actual gains that you need to feed to your actuator. Okay, so we do have a library that will let you do this. So we provide it free of charge for you, and I guess our fees kind of difference from maybe conventional or other free PID library is that ours does support an auto tuning of PID parameters and the gain parameters for you. Okay, so basically the concept is simple, but actually the hard part of doing the PID is the tuning part, and we do provide the auto tuning in the function blocks we have. Okay, so I think we're almost to the end. So this is an application of kind of like in-house oven that was made exclusive with our CMT Codesys and the remote I/O of our own product. Okay. So just as I said, so the temperature information was feedback to our temperature input, and then we'll calculate with the Codesys PID library to get a gain to feed to the relay, and then to control the amount of power that goes to the oven. Okay, so it's just an example that this simple setup how it actually did for this little in-house application. So we set it to 50 degrees, and we reach a steady state error of less than 0.1 degrees Celsius so this control was doing pretty well with our library. And just as a very last, I just show you how you add the libraries to your program. So if you come to the library manager in your Codesys and you go to library repository and you click install, then if you have any compile library, which we provide, so when we provide you, it would be like a compile library form, so like this one. So you can add this to your what's called the repository. Okay, and then once it's in your repository, and you can add the library to your project. So I can add. So this is, like I said, it's the only one we provide as of now. Okay, so once you have added in your project, then here you go, you can use it. So how do you use it? Basically, just as a starter, you basically you declare it in the variable list, and you can do it this way. So here I want to initiate an instance of my PID controller. Okay, so my instance is called my PID, and okay, I want to put this into my program. I just drag a new box and then select my instance of my function block. Okay, and there you go. So that's our Weintek PID function block. Then you can use, and you can define. You can use different variables for this. Just example, yeah. For all the inputs and outputs of this function block, and you can move on with all your project. Okay, so well, it's a little bit over by a few minutes. That was it. That was what I have for today. So thank you for bearing with us.